Let's move to capital market line. Capital market line. My name is Mr. William of Fatima Institute Center for CIFA Studies. My numbers are just as you can see in the footnote of this textbook. I'm a publisher as well as an author of these textbooks. So in case you need any support from my side, you can contact me from the same number. We also offer online classes and physical classes, revision classes, and we are based in Thika town. Let's go through capital market line. The theory part, I think we discussed that during the physical classes. My major concern is the computation of expected return using the capital market line and establishment of whether a security is overvalued, undervalued, or correctly valued. So in the absence of risk-free securities, all efficient portfolios will be found along the efficient frontier curve. But there exists some securities in the market which do not contain any element of risk. Such securities will be called risk-free assets, such as treasury bills and bonds. If risk and riskless assets are combined to form a portfolio, a line extended from the risk-free rate to become tanked to the efficient curve set at the market portfolio is called the capital market line. The capital market line is an efficient set of risk-free and risky securities, and it shows the risk-return trade-off in the equilibrium. The CML indicates the risk and return relationship of a portfolio consisting of risky and riskless assets, diagrammatically represented as follows. When you talk of risk-free securities, they are the securities which have no risk, especially government securities like treasury bills and treasury bonds. So those are the risk-free securities. Now let me show you the diagrammatic representation of the capital market line. From the other page, that is page 102, you'll find diagrammatic representation. You find diagrammatic representation of security market line. You can go through it. I've said my major focus will be calculation, and then after that, understand my formula which I'll be using for calculating expected return of a portfolio. I'll be using risk-free rate plus expected market return minus risk-free rate over standard deviation of the market times the standard deviation of the portfolio. So this formula is quite important. So our CML formula will be using this formula here. Risk-free rate plus ERM minus RF over SM times SP. That will be our formula that we will be using. Now the rest now is the theory part. I leave that theory part to you. I believe most of you have this textbook, the revision book, and I believe I told you to read about the theory for the capital market line. Mine was only to show you how to calculate the expected return of security or portfolio using the capital market line, and our formula is there. So try to go through those notes. Now from there, you move now to page 102. I have summarized what is important because my major concern was calculation. Understand the formula that you'll be using because you'll be computing the expected return, which is known as the intrinsic value, and then we compare it with the expected return as given by the market. Compare the two. So the difference between what you have computed with the expected return as provided for by the market forms the basis of whether a security is either overvalued, undervalued, or correctly valued. So I believe you have understood what we are saying. Now move to page, you can pause your video and maybe you do not have this book. If you do not have this book, because you may be following from foreign countries and you may not have sent to you a soft copy, you can just have that diagram there. Understand these formulas which you have given here. Remember, you are doing capital market line, and then understand the formula, then go through those notes as they appear in this one of my published books. Once you're through that, you go to page 103. Now from page 103 is where you start our question, or I'll show you the formula again. Once again, you can see our formula there. You'll be taking to calculate expected return using capital market line. You'll be taking risk-free rate plus into brackets expected market rate minus risk-free rate. This risk-free rate is the same as this one, divided by the standard deviation of the market, then you multiply by the standard deviation of the portfolio. Okay, so that's important. This point here, the slope of the capital market line is often called the market price of risk and equals the reward to risk ratio or sharpest ratio. We'll be taking the sharpest ratio later on. You'll find that the sharpest ratio is very close to this formula that we're using here. We'll be taking that one next week or in a few days time for the market. For this is calculated as this formula here. Now the other part is that theory which is in our textbook. You can go through that theory. You read all that theory to understand the concept of capital market line in details. But if you are studying this for the purpose of examination, what is very important is understanding how to calculate the expected return using capital market line. Therefore, you should have understood this formula here. You understand once you take an example, and then comparing the intrinsic value which you will have calculated with the market returns. So straight away, we take an example for you to understand better. We take two examples. The first example. 5 investors have different portfolios with the following features. And our portfolio, remember, means investment in different assets. Usually say that don't put all your eggs in one basket. So if you have invested in different assets, so those different assets constitutes a portfolio. So we have portfolio A, B, C, D, E. Then the expected return is for A is 14%, for B 12%, for C 11%, for D 15.2%, for E 17.5%. The standard deviation for each portfolio has been given: 6% for A, 7.5% for B, 5% for C, 11% for D, 13% for E. The market portfolio is offering return of 10% and standard deviation of 4%. The risk-free rate is 6%. Required: using capital market line equation, identify the efficient and inefficient portfolio. So you'll be calculating the expected returns using the formula that I've shown you up there. So kindly pause your video and then you take this information so that I may move now to the next page. Kindly take this that question there, portfolio A up to E, then the expected returns, then the standard deviation. So once we calculate the expected return using capital market line, we'll be comparing our answers with these expected returns to establish whether that particular portfolio is undervalued, overvalued, or correctly valued. So take up that. Then we move to page 10104. I believe you have taken up. Those figures. Take up those figures because I'm moving on the next page. You'll be referring. Yeah. So let's have our solution now. Now our solution. Remember, you have said capital market line. You'll be taking risk-free rate plus as the SP over SM times ERM minus RF. Now risk-free rate, you have said, is 6. The risk-free rate is 6. If maybe you have not understood what I'm saying, is that you've been told that the market portfolio is offering return of 10% and standard deviation of 4%. The risk-free rate is 6%. So this risk-free rate for the market is the one that you bring it here now. The risk-free rate 6 plus. Now you have SP. SP is the standard deviation of each portfolio. The SP now, the standard deviation for each portfolio. So for A, you take 6. The standard deviation for each portfolio, you are using 6 over SM. The SM will be the standard deviation of the market, constant standard deviation of the market. So you divide by 4, and then from there divide by 4. Then you multiply by expected market return, which is 10, minus risk-free rate, which is 6. This risk-free rate is the same here. This 6 here. So this risk-free rate is the same as this one here. So the only thing which changes in all this is now this 6, 7.5, 5, 11, and 13. All the other numbers remain the same. The only thing which is changing is 6, 7.5. What is changing is the standard deviation of each portfolio as far as our formulas are concerned. Only these ones are changing. All the others remain the same. Now, once you have done that, I believe you have understood. So you are taking risk-free rate, which has been provided for each portfolio. It is the same throughout. Then 6, we have 7.5. For C, we have 5. For D, 11. For E, 13. You are dividing by 4 throughout, multiplied by expected return of the market minus risk-free rate. This risk-free rate of 6 is the same as this. Now, once you work out that, your capital market line will be these numbers. For A, 12%. For B, 13.5%. For C, 11%. For D, 17%. And for E, 19%. So remarks, want to see whether these portfolios are overvalued, undervalued, or correctly valued. So go back to the previous page where the question is, because you'll be comparing these expected returns which you have calculated using capital market line, compare with the expected returns by the market. If what you have calculated is more, if what you have calculated is the same as what is provided for by the market, then that portfolio is correctly valued. But if it is less than or more than, then you'll be talking about either overvalued or undervalued. I want you to take up this again. So you'll be comparing what you have calculated with 14%. Now, for example, for portfolio A, what we have calculated is 12%. Now, note here, what we have is expected return for A is 14%, but our capital market line, we have 12%. So 12% comparing with 14, then that security is undervalued, because we are talking about capital market line at 12%, then expected return being 14%. For B, you have 12% for B, 12% for B expected. Our calculation using a capital market line, what do you get? 13.5. So 13.5, we are comparing with the 12. 13.5 is more, so that is overvalued by the market. For C, we have 11%. For C, we have 11%. And what we have calculated for C? Is 11%. So that is efficient, or it is correctly valued. So you can check D and E. Compare what we have on the other page, what we expected, and compare with 17. Then for E, compare what is expected with 19, and you realize that those items are overvalued. So basically, to establish whether a security is overvalued or undervalued, you just be comparing these numbers here, these expected returns. 14% compare with what you have calculated. 12% for B, 11% for C, 15.2% for D, and 17.5% for E. You'll be comparing with these numbers which you have calculated. So that forms the basis of whether a security is either overvalued or undervalued. That forms the basis of whether security is overvalued or undervalued. Example 2. Let's move to example 2, and you are told 6 portfolios are available for investment with the following characteristics. Portfolio A, B, C, D, E, F. We are doing example 2. Expected return of the portfolio for A all the way to F is 25, 16, 19, 32. That is 8.9%, not 89, then 22.5. Standard deviation for each portfolio 12, 6, 8, 16, 2, and 10. Expected return on the market portfolio is 12% with a standard deviation of 4%. The risk-free rate of return is 5%. Required, using capital market line, advise the investor of the portfolio that is undervalued, correctly valued, and overvalued. So your question is there. And number 2, in case of an inefficient portfolio in one above, determine the standard deviation that should be achieved for efficiency to be arrived at. So follow that example. Now we do the same. I've given you the formula there, just like the other which you have done. You take risk-free rate. You are told the risk-free rate of return is 5%. So the risk-free rate, you can see it is 5 throughout. Then you plus the expected return on the market. Expected return of the market is 12. That does not change. It will be the same throughout because you have on the same one market. Then you minus risk-free rate. The risk-free rate does not change. Is 5 over standard deviation of the market. Standard deviation of the market, we are told, is 4%. You divide by 4. That does not change. Then what changes now, in this case, is the standard deviation of the portfolio. So you only be multiplying now by these numbers here for each respective column. You multiply by 12 for A, 6, 8, 16, 2, and 10 for each respective portfolio. So you can see what you have done here. If you look at this solution here, you find that the only thing which is changing is what? QP, these numbers here. All the others are the same. Now once you have understood that, the required return now, the required return you compare with expected return. You compare the expected return with, compare the expected return with the required return. Now you can see your expected return as per the question is 25, 16, 19, 32, 8.9, and 22.5. So just place them there. Required return, the required return, the ones which you have calculated, compare with the expected return as per the question. If the expected return, if what you have calculated is more than the expected return, because what you have calculated using your formula is known as the required return, you compare with the expected return. If the required return is actually the intrinsic value which you have calculated, if the intrinsic value which you have calculated is more than the expected return as provided, then that security is overvalued. For example, security A, 26 is more than 25, so that is overvalued. For B, 15.5% is less than 16%, that is undervalued. For C, required rate of return is 19%, expected is 19, that is correctly valued. For D, that 3 is more than that 2, overvalued. E, 8.5 is less than 8.9, undervalued. For F, 22.5 is the same as 22.5, that is correctly valued. Now there is question number, so required number 1, you are told using capital market line and advise the investor on the portfolio that is undervalued, correctly valued, and overvalued. So we are able to answer that on our comment column. You have that column where we have made a comment there. The securities which are overvalued, the ones which are undervalued, the ones which are correctly valued. We now answer number 2, Roman number 2. In case of an investment portfolio in one above, determine the standard deviation that should be achieved for efficiency to be arrived at. Now, efficiency can only be arrived at if the required return is equal to the expected return. In other words, what standard deviation can we use so that our required return equal to the expected return? The securities which are inefficient, we've seen are security A. In other words, those securities which are overvalued, A and D, the ones which are overvalued. We want to see what percentage can we use so that our expected return, for example, for A, we get 25. That's the question that we are using. Now, make a follow-up here for portfolio A. Portfolio A. See what I've done there. I've used Biro. Portfolio A, we want to establish the standard deviation that we can use so that our required return equals to 25. So 5 plus 12 minus 5 over 4. But now we will not use 12, we use x. You say x because you are looking for x. That is standard deviation that we can use to make the expected return 25% so that it is correctly valued. Because we are saying a security is correctly valued if the required return as calculated is equal to the expected return as provided for. So see what you have done in our part A. You have just taken the formula and the same numbers that we have used in calculating the required return, but for standard deviation we are not using 12, we are using x. We are calling that x. So we solve for the value of x. We solve for the value of x, then we equate it to 25 because we are looking for that rate that when we use it, our answer will be equal to 25. So you have taken 5 now. You solve for that. 12 minus 5 is 7. 7 over 4. 7 over 4 is 1.75. X is equals to 25. So 5 plus 1.75x is equals to 25. Then 5 will move on the other side and it will be a minus. So it will be 1.75x is equals to 25 minus 5. So 1.75x is equals to 20. Divide both sides. Therefore, you divide both sides by 1.75. So 20 over 1.75 is equals to 11.43%. Now you can prove that if you use, it means that if you use 11.43% as your standard deviation, that is for portfolio A. If you replace 12% with 11.43%, your answer should be 25%, so that your required rate of return will equal to the expected return, 25. So you can see what you have done there. If you replace 12 with 11.43, you can see working there what you have done. We have proved that down here. So I've said here, proof proof for portfolio A. Proof for portfolio A. So here this X I have replaced it by 11.43 and I'm getting 25. Finally, I'm saying I'm getting 5 plus 20, which is 25. So if instead of using 12 here, I use 11.43, my required return will be 25, and therefore required return will equal to expected return 25, 25, and then that security will be correctly valued. The other is portfolio D, 5 plus, we do the same, 5 plus 12 minus 5 over 4. Instead of using 16, we use X. You call that X. So here we use X instead of 16. Then we go on. 5 plus 7 over 4, X is equals to 32. You see, we have to equate it. We are equating with 32, the expected return. 5 plus 7 over 4, close the brackets, multiplied by X is equals to 32. 5 plus 1.75, because 7 over 4 is 1.75x, is equals to 32. 1.75x, 5 will cross the other side, 32 minus 5. Then we have 1.75x is equals to 27. Divide both sides by 1.75, and 27 over 1.75 is equals to 15.43. So we should use standard deviation of 15.43 instead of 16. You replace here, if you use 15.43, then here you will not get 33%. You get that too. And you have proved that here, proof for portfolio D, if you use 15.43 instead of 16, your answer is 32. That's 2 here. So you can see the required return will be that 2, the expected return will be that 2, and therefore that portfolio will be correctly valued. I don't know whether you have any challenge. So you can go through your question, go through your example. Just go through your example. You have your example there. Example is there together with the solution. My numbers are down there. Kindly subscribe to our YouTube channel so that whenever we upload a video, you are able to be notified, most especially if you are waiting for an examination. These videos are very helpful because they are quite simplified, and we are taking them from our published materials, which we have done a lot of research on. However, if you find anything that has not been done the right way, maybe typing error, or maybe a concept has not been explained well, feel free to call us, or you communicate through our YouTube channel. Just make a comment to help us to improve on these publications. And that is all for that. Now, before I leave, I can get a question from past papers. I don't know whether it will be legible. Let's try to see whether this question is legible. Now there is a question there. There's a certain question here which can be good for you. This question can be good for you. You are told that it's coming from KASNEB, Advanced Financial Management for CPA, Advanced Level, August 2023. Now the question is there. You're being told Simon Cobier, an investor, is evaluating 6 portfolios with the following characteristics. Portfolio 1, 2, 3, 4, 5, 6. Expected return of the portfolio, we have 19%, 25%, and all that. Then standard deviation of the portfolio, the figures have been given there. Then you are told the expected return. Now I'll read it from here. You are told the expected return of the market portfolio is 12% with an accompanying standard deviation of 4%, while the risk-free rate of interest is 5%. Required 1. Using capital market line, advise the investor on which portfolio is inefficient, efficient, or super efficient. Number 2. In case of inefficient and super efficient portfolios in C1 above, compute the standard deviation that the portfolio should have for efficiency to be achieved with a given expected return. Now you can just you can attempt that question. I think you are able to see that. So you are simply going to calculate expected return using the capital market line, just like the ones that you have done. Then the answers you'll be comparing with these expected returns, establish whether those securities are overvalued, undervalued, or correctly valued. Then number 2, I've shown you how to establish, how to calculate that rate which can be used, or the standard deviation that can be used to make that particular portfolio to be correctly valued. That is enough for today. So we meet next lesson as we continue doing other different things. Kindly subscribe so that we may update you as we continue with our classes. Thank you and have a good night.